Good morning, students. Now HS second year mathematics. We are doing calculus. Already we have completed continuity as well as chain rule. We have finished chain rule of differential calculus. Now we will do the differentiation in an implicit explicit function. That is from exercise 5.3. Already we have done up to question number 3 of exercise 5.3. Now question number 4. It is given what xy plus y square is equal to 10x plus y. So this is our question, xy plus y square 10x plus y. What we have to find? We have to find dy dx. So rule already we have said we have to differentiate both the side with respect to x. d dx. d dx we have written in both the side. That is the rule already we have used, and then we have the knowledge that we can write like that. What we have done here? We have written d dx of this. Here we have taken d dx to individual all terms. I have written d dx of xy, d dx of y square, d dx of 10x, dy dx. It is UB form, product of UB. Y we will keep, x we will keep outside. First I have taken y outside, then I have taken x outside. Now here it is what? Y square. We have to differentiate with respect to x, which is not possible. So we will do here chain rule, and it is what? dy square dy and then dy dx. This term dy square with respect to y will give twice y. This is dx. It is what? dy dx. We have kept like that. Differentiation of 10x is what? Sec square x plus dy dx. So we get these things. Now we will take all the dy dx term in one side, remaining all in other side. Dx by dx is what? 1. And if we take all the term here and taking dy dx common, it will be x plus twice y minus 1, and here sec square x minus 1. So this is our condition where we have taken all the dy dx in one side, other non-dy dx in other side. This implies dy dx is equal to sec square x minus y by x plus twice y minus 1. So here we have done with that procedure. Already we have done this type of sum. So we have done like that, and this is our question number 4. Now question number 5. Question number 5. Here it is also the equation form. It is what? X square plus xy plus y square is equal to 100. This is our question. Now if we differentiate it with respect to x, then yes, just like earlier one, yes, I have differentiated with respect to what? Dx. Then what we will do? We will break it. Dx square dx, dxy dx, dy square dx is equal to 0. This is things, this term, that term we have isolated. Dx square with respect to x, it is what? Twice x only. Here u into d form. So y we will keep. Then we will take x outside, x dy dx. u into v form, Leibniz product rule, y, then x differentiation, x outside, then y differentiation. Here y square with respect to y, so of course it is this, we can write chain rule we have applied, so it is twice y dy dx is equal to 0. So now we will get this term has dy dx, this term has dy dx. If we take dy dx common, then we left with the x plus twice y. This one minus twice x, dx by dx is 1, so it is y only. So what will be dy dx? Dy dx will be minus twice x plus y by x plus twice y. So this is our question number 5, and it is of course of similar type of this one. Now as question 6, it is of same type, so I want to give this one as homework, and I expect all of you will do, and definitely you can able to do. So now I will go for 7. 6 is similar like 5, that's why I have skipped. Remember that one. But still, if you fail to do, then yes, you can ask me, I have no problem, I will explain. Now we will do for question number 7. Sine square y plus cos xy is equal to k. So this is our question. So this is question number 7, and we have to find, what we have to find? That dy dx. So as usual, what we will do? We will do d dx on both the sides. What we have done? We have taken d dx on both the side. Then here you see that d sine y whole thing square. If I break this one, automatically something square, you have to use chain rule. D sine y you will write, and d sine y you will write with respect to y, then dy dx. See here, what I have done? First sine y whole thing square with respect to sine y you have differentiated. Then differentiation of sine y with respect to y I have written. Then dy dx written. It is the chain rule. It is our rule that we will use chain rule for that one. Now we will differentiate this one. Differentiation of cos xy. Here xy is there, so we have to differentiate with respect to xy. Then dxy with respect to x you will write. Differentiation of k is 0. I want to repeat again. Sine y whole thing squared we have differentiated with respect to sine y, then sine y with respect to differentiate y, then dy dx, then cos xy with respect to xy, then xy I have written. Student, you watch minutely. Of course, I think you can able to understand this one. dy square, dx square dx with respect to x. Differentiation of x square with respect to x is twice x. With the formula dx and dx in that one. So here also, if we think of this one, it is twice sine y, it will be, think that y is, sine y is what? X. Differentiation of sine y is what? Cos y, dy dx. Now differentiation of cos x with respect to x is what? Minus sin x. Here in place of x it is what? Xy. So what you will do? You will write minus sin xy. Then differentiation of xy. Already we have experienced with this one. Y will keep dx. Then x we will write dy with respect to x we will write. Now students, this one is what? Sin twice y. And from this term we can get what? X sin xy. We can get what? Dy dx. So what we have written? Twice sin y cos y is sin twice y. And from this term x sin xy, dy dx is there. We have taken dy dx common. Now this term dx by dx to 1 into y is y sin xy. If you take in this side, it will be y sin xy. So this is our procedure for calculation of dy dx. So what is dy dx? Y sin xy by sin twice y minus x sin xy. So this is our question number 7 it is. So I expect you understood this one. This is question number 7. Now we move for question number 8. Question number 8 is what? It is written sin square x plus cos square y is equal to 1. And we have to find what? Dy dx. Now see, if we differentiate again with respect to x, then this already we have experienced with this one, sin x whole thing square. With respect to d sin x, it is the rule. Then we have to differentiate sin x with respect to x. Then it will be this one. Similarly for cos y, cos square y, d cos y whole thing square with respect to d cos y. Otherwise you cannot differentiate. Then differentiate cos y with respect to y. Then differentiation of y with respect to x is equal to 0. 3 times chain rule we have written here. Cos y whole thing square with respect to cos y. Then differentiation of cos y with respect to y. Then dy dx. Now we get what? This with respect to this is twice sin x. Differentiation of sin x is what? Cos x. This one we get, as we know, twice cos y formula. Differentiation of cos y is minus sin y, so we will write here minus sin y, and dy dx is equal to 0. Now this one is what? Sin twice x. If you take this in that side, this value is what? Sin twice y dy dx. So what is dy dx here? Dy dx is sin twice x divided by sin twice y. So this is our value. It is what? Sin twice x by sin twice y. So I think it is clear to all of you. So this is question number 8. Now question number 9. Question number 9, they have given a peculiar time type. It is what? Y is given sin inverse twice x by 1 plus x square. We have to find dy dx. So of course it is what some substitution is required. We have to make it in simplest form of this one. Then you will differentiate. For that you have to substitute let x is equal to tan theta. I have substituted what? X we have replaced by tan theta. Why we have done? To make it in simplest form. Y sin inverse twice tan theta divided by 1 plus tan square theta. What we have done? We have just replaced x by tan theta. Then we get sin inverse of this one. Now this term is what? In class 11 we found this is what? Sin twice theta. This is the formula of what? Sin twice theta. Now see, sine and sine inverse will cancel each other and we will left with what? Dy as twice theta. Theta is what? 2 tan inverse x. From that we can write theta is what? Tan inverse x. So dy dx it will be what? If we differentiate tan inverse x, it is 1 by 1 plus x square. So this is the value of dy dx. And yes, of course, this is what? After completion of making it in simplest form, then you have to only differentiate. Otherwise, it will be a very tiresome one. So that is the procedure. Now we will do question number 10. Question number 10, it is given like that. Y is equal to tan inverse thrice x minus x cube by 1 minus 3x square. This is our y. Now if we put here again x equal to tan theta, then we will get tan inverse 3 tan theta minus tan cube theta 1 minus 3 tan square theta. I have written in place of x, I have written tan theta. Why written? Because if I write, this is formula what? Tan 3 theta. So we will get y as what? Tan inverse tan 3 theta. So y becomes here tan and tan inverse will cancel 3 theta. Theta from here we can write as tan inverse x. So dy dx it will be what? 3 and differentiation of tan inverse x is 1 plus x square. So this is our question number 10. Student, you see this is what we can do like that, and of course it is what? This way we can solve. This is our question number 10. Now we will do for question number 11. Question number 11 we will do. It is in question number 11 we will write question number 11. Here y is equal to cos inverse 1 minus x square by 1 plus x square. This is our question number 11. 11 we will do like that. It is what? This way we will do, and this way here we will use a little same substitution we will do. Substitution is what? That we will write x is equal to tan theta. Why? We will get this answer. Cos inverse 1 minus tan square theta plus 1 by tan square theta. Now this will give what? 1 minus tan square theta, 1 plus tan square theta. This gives cos twice theta. It is formula. Cos twice theta. Then cos and cos inverse will cancel each other. We will get what? 2 theta. That is 2 tan inverse x. Similar type. So dy dx will be what? 2 1 by 1 plus x square. This is our question number 11. Now question number 12. Here it is given what? We will do question number 12. 12 is like that. It is y is given as sine inverse. Y is given sine inverse this. So here you will find y is what? Sine inverse of 1 minus x square by this one. Same substitution You just replace this by sine inverse. Then one problem it is what? Sine inverse this one. Technique you just see, it is what? I have again in this case also I have written this one as like that, and this will give that one. That is our problematic. I am again explaining what happened here. You will find it is what? If we replace x by tan theta, 1 minus tan square theta by 1 plus tan square theta, this is cos twice theta. Then I will change this one by sine. How it is possible? 90 minus twice theta. Sine 90 minus theta is what? Cos twice theta. So that is formula. That is the formula for that one. And we have taken sine only to cancel each other. So these two will cancel and we will have to what? Y is equal to pi by 2 minus twice theta. Pi by 2, 2 theta. Theta is what? Tan inverse x. Therefore dy dx is equal to, if we differentiate 90, it is the 0 minus tan inverse x is 1 by 1 plus x square. So this is our question number 12. It is similar like that of earlier one. Now we will proceed for question number 13. I am showing this sum because this is a complicated one, so of course you need some. So now proceed for second sum. Here question is y is equal to cos inverse twice x by 1 plus x square. Question number 13, y is equal to cos inverse twice x by 1 plus x square. So how we will proceed? You just see. So that same way we will do. X you will put as tan theta, cos inverse twice tan theta, 1 plus tan square theta. This is value of what? It is sine twice theta. Already we have experienced this one, how to do that one, that we have written. Then y becomes cos inverse. Sine twice theta can be written as cos 90 minus twice theta. We get, if both are cancelled, then we get 90 by this. So 90 minus 2 theta. Theta is what? Tan inverse x. So after differentiation dy by dx, 90 is 0, this is minus, this is 2, this is 1 plus x square. This also gives same value, same thing. Just to concentrate with this one, it is what I have written in similar way, same thing. So I expect you understood this one. Now question number 14. 14 is given y is equal to sine inverse twice x by y is equal to sine inverse twice x root over 1 minus x square. This is given. Here substitution is little bit different. What you will do? You will put let x equal to sine theta. Earlier we have taken x equal to tan theta. Only here we have taken sine theta. Intention is that we will convert, able to find a sine term so that sine inverse will cancel. If we put here x as sine theta, it is twice sine theta root over 1 minus sine square theta. What we will get here? Sine inverse twice sine theta, and 1 minus sine square theta is cos square theta. Root over will make only cos theta. Now students, you see, it is 2 sine theta, this gives cos theta. 2 sine theta into cos theta, it is what? Sine twice theta. Now see, these two will cancel each other. We left with what? 2 theta. Theta is what? Sine inverse x. Because x equal to sine theta, theta becomes sine inverse x. If we differentiate dy dx, it will be 2, and this is what? 1 by 1 minus x square. So it is the value of that differentiation. Yes, I again want to repeat this one. X is here replaced by sine theta. Then we get y is equal to sine inverse 2 sine theta root over 1 minus sine square theta 2 sine theta. This will give cos theta. Then sine inverse, this is actually sine twice theta formula. Sine and sine inverse will cancel, twice theta left. Theta becomes sine inverse x. So if we differentiate this one, 2 sine inverse x is root over 1 by root over 1 minus x square. Now we will go for question number 15. 15, it is the last term of the exercise. It is given y is equal to sec inverse 1 by 2 x square minus 1. Here, if we take x equal to cos theta, let x equal to cos theta, then we get what? Y is equal to sec inverse 2 cos square theta minus 1. Yes, we have replaced x by what? Cos theta. Sec inverse. Now 2 cos square theta minus 1, we have formula what? It is what? Cos twice theta. So 2 cos square theta minus 1 formula is cos twice theta. This gives 1 by cos theta is what? Sec twice theta. 1 by cos twice theta is sec twice theta. Both will cancel. We left with what? Twice theta. That means 2 cos inverse x. Now if we differentiate with respect to x, it will be 2 minus 1 by root over 1 minus x square. Differentiation of cos inverse x is this. So it is the formula of cos inverse x is this. So it is the dy dx. Students, we have completed exercise 5.3. Now we will proceed for exercise 5.4. 5.4, if we do, then it is question number, first question is given e to the power x by sin x. Here we have to differentiate e to the power x by sin x. We have already have the formula of u by v form. This is u, this is v. Then what it will be? V square, that is sin square x. Then you will keep sin x and differentiate e to the power x with respect to x. Then you will keep e to the power x, then you will differentiate sin x. So this is the rule, this is the way we have to do. And then differentiation of e to the power x, it is what? E to the power x. Differentiation of sin x, it is what? Cos x. Now if we take e to the power x common, it is sin x minus cos x by sin square x. Here we have done what? We have used, it is e to the power x by sin x, it is given. So we will write it is in the form u by v. U by v differentiation is differentiation of this one, keeping denominator 1 first, then minus differentiate this one, denominator 1, keeping this one at the beginning. Whole thing divided by denominator square. e to the power x differentiation is e to the power x, sin x differentiation is cos x. Now just only simplification, e to the power x I have taken common. If I take e to the power x common, sin x minus cos x divided by sin square x. So this type of questions we will get in question number exercise 5.4. Student, I think you understood this one. That much for today's class.